In this module, we're talking about oxidation reduction, also called redox reactions. So a redox reaction is one where something loses electrons and something else gains electrons. Whichever species gains electrons is basically pulling them away from the one that's losing electrons. So this picture here is a picture of a beaker of aqueous copper ions. So that blue solution there has copper 2 ions in it. And this is a strip of just zinc metal. It ends up when you put a piece of zinc metal into a solution of copper, the copper ions rather, the zinc metal loses electrons and the copper ions gain the electrons. So 2 electrons come from a zinc atom, go on to copper, and what happens is you get copper metal. Now the copper ions, they're dissolved in solution because they have charge, and so the water molecules solvate them. But when they have no charge, it's just solid metal copper, and you get a coating of copper on the surface of the zinc. This is a redox reaction. The copper's ion is gaining electrons, and the zinc ion is losing electrons. Now, if we were to try to do it the other way, it ends up, if we were to put a piece of, this is the wrong picture, piece of copper metal into a solution of zinc, we'd see nothing happens. And the basic reason for that is that this is a tug of war for the electrons. It ends up that copper is stronger than zinc. And so zinc's not strong enough, the zinc ion is not strong enough to pull the electrons away from copper, but copper can pull them away from zinc. So we see a reaction here, we don't see one here. Now, some terms. Whatever is losing its electrons, we say it's oxidized. Whatever is gaining electrons is reduced. There's a mnemonic that help me to remember it. It's oil rig. Stands for oxidation is loss of electrons, reduction is gain of electrons. So remember what oxidized means and what reduced means. Now, if that's not enough, we call the species that's being oxidized, it's called the reducing agent. It's the means by which something else is oxidized. It's something else is reduced. And the thing that is being reduced is called the oxidizing agent. It's the means by which something else is being oxidized. So let's look at this reaction right here. Solid magnesium metal and hydrogen ions from an acid. And what happens is when you put magnesium metal in an acid with hydrogen ions, the hydrogen ions pull electrons off of the magnesium, and you make a magnesium with a +2 charge and neutral hydrogen over here. Now, just looking at this reaction, you would be able to figure out that as magnesium goes from the left to the right, it's losing 2 electrons because here it has a 0 charge, here it has a +2 charge. The only way that can happen is if it lost 2 electrons. And losing electrons is oxidation, so magnesium was oxidized, and it's the reducing agent. Hydrogen ion, on the other hand, has a +1 charge. Each has a +1 charge here. Over here in this neutral molecule, it has 0 charge. So going from +1 charge to 0, the only way that can happen is if it gains an electron. It's being reduced, and it's the oxidizing agent. So magnesium is the agent by which hydrogen was reduced. So that's why it's the reducing agent. And hydrogen is the agent by which magnesium was oxidized, so it's the oxidizing agent. Magnesium was oxidized, hydrogen ion was reduced. Now, we're going to need to calculate something called oxidation numbers. And the way you do that is just you apply this hierarchical list of rules. Hierarchical, right, just means that when 2 of these rules conflict, the one that's higher up in this list wins. It beats the one that's further down. So rule number 2 beats rule number 3, and so on. So look at these, put them on your card, memorize them. The neutral element, it's oxidation number 0. Number 2 we use a lot. When we add up the oxidation numbers in a compound, they must equal whatever the charge on the compound is. Now, if it's 0, they add up to 0. If not, they add up to whatever the charge is. Fluorine's -1. It beats everything else down here. So now what we have is a hierarchical list of oxidation numbers for specific elements. Fluorine is -1, oxygen's -2, unless it's in something called a peroxide, like hydrogen peroxide, H2O2, then it's -1. Group 1 metals are +1, that is lithium, sodium, potassium, rubidium, cesium. Group 2, beryllium, calcium, magnesium, strontium, barium, are +2. Halogens, so fluorine is a halogen, right? But the reason it's up here is that because it beats the other halogens. So chlorine, bromine, iodine, these are -1. Hydrogen's +1 and nitrogen's -3. So remember, if something higher up beats something lower down. So let's say we needed to calculate the oxidation numbers in the dichromate ion. So the way you do this is it's always going to be the case that either there's a rule for all of the elements except for one. If that's the case, then what you do is you write in the oxidation numbers for the ones that you know and leave the one that you don't know as an unknown. So here, dichromate is unknown. Now, sometimes you will have a rule for all of the elements in the compound. What you do then is you leave the one that's the lowest in the list unassigned. So let's say we had a rule for chromium, but it was real low in the list. So we would still do it this way. And then you solve for the one that you don't know. So here we don't know chromium. There is no rule for chromium. So there's 7 oxygens. Okay, that's what the 7 is for. The -2 here is from the list. It said that the oxidation number for oxygen is -2. So that's where that -2 came from here. And it has to add up to be -2. This -2 came from the overall charge on dichromate, -2. So if we solve this for the oxidation number of chromium, it's +6. And so we know now in the dichromate that the oxidation number for chromium is +6 and oxygen is -2. We got that from the rules. Now, in a chemical reaction, in order for it to be a redox reaction, something has to be oxidized and something has to be reduced. And what that means is the oxidation numbers are going to change as you go from left to right across the arrow. Now, whatever's being oxidized, the oxidation number is going to become more positive or less negative as you go from the left to the right. Whatever is being reduced, the oxidation number is going to become more negative or less positive. So let's apply that. So the combustion of methane, this is CH4 plus 2O2 goes to carbon dioxide and 2 waters. So applying the rules for methane, we have a rule for hydrogen but not for carbon. So we leave carbon unassigned. We put hydrogen's oxidation state as +1. There's 4 hydrogens. 4 times +1 plus carbon equals 0 because there's no charge. And that ends up being carbon is -4. Now this is just an element by itself, so we know that oxygen is 0 over here. On the right-hand side, we do the same thing. Now here, okay, again we have a rule for oxygen. It's -2, so there are 2 oxygens times its oxidation state -2. Carbon we leave unassigned. We solve for it, and it ends up that it's +4 on the right-hand side. And over here, if you do the same thing for water, you see that it just fits in with rules. Hydrogen's +1, oxygen's -2. So carbon in methane, CH4, is going from -4 to +4 in carbon dioxide. That's becoming more positive or less negative, and that's oxidation. Oxygen is going from 0 on the left side of the arrow to -2 both here and here on the right-hand side of the arrow, so it's being reduced. Its oxidation number is becoming more negative, less positive. So we know that carbon's being oxidized, and that means carbon is the reducing agent. Oxygen's being reduced, that means it's the oxidizing agent.